Hi everyone. Today what we're going to work through is slope of a line segment. You can see that on the top of the screen right now. What I want to make sure is that we don't kind of push off or slag off today because you go, we've already talked about slope. Yeah, I'm good. I understand slope. We're going to actually look at slope in a little bit of a different way today. That what we want to be able to do is to talk about slope without ever seeing a line. So up until this point, we should have been very comfortable to have a diagram to describe slope, to have a graph and be able to examine slope. Today, we're going to kind of take that next step. So at the very beginning then, for us to be able to talk about slope of a line segment without seeing it, we need to first start to address the graph of it and be able to walk through a certain sort of relationship that we can see. So we're all going to start off going through a little bit of a discovery activity. Now, what I want you to do is I want you to go through and deal with this independently. That doesn't mean on your own, but what I mean is I don't really want you to have the same thing as me today. That is, as we begin this process, I actually want you to have a different line segment on your grid than what I have. And I think the fact that we have something different will actually help us to understand our theory a little better. So what I'm going to do is just shrink down that grid a little bit so we can focus in on the instructions underneath. So we're going to go through and we're going to do a little activity. And you're going to have a series of instructions that I need you to follow. So let's start it off in bits. Well, the first thing that we're going to do is we're going to focus in that we need to draw a line segment somewhere on our grid. But that line segment has to have some properties to it. It has to have a slope that is not equal to 0 nor undefined. So we cannot draw a horizontal line or a vertical line. It has to be a line segment that has some slope to it. Okay, what I want you to do, pause the video now and draw your line segment. Okay, we're back. Now what I'd like you to do is to examine the second instruction. That second instruction says to label the line segment AB. But before we just put on our labels of A and B, we have to see there's some specific instructions about how to do that. A is going to be the higher end point and B the lower end point. Okay, so since we have drawn on a line segment that is not horizontal, one of those endpoints should be higher than the other one. Label the higher one A, the lower one B. Once you've done that, I think we should be able to then jump in and label the coordinates of A and B as well. So we're going to actually write on the coordinates on our picture. Okay, I want you to pause the video and go ahead and do those two things. Okay, we're back. So I'm going to go through, and again, hopefully we have something different. So for me to start off, I'm going to draw on my line segment. And maybe I just say that I have a line segment that goes from up here, and maybe I go like all the way down there. So I'm going to connect those with my straight edge and draw on my line. Now my labeling instructions say A is the higher end point, so this point must be A, this one must be B. And then it tells me to label on my coordinates. So A would end up being at 3, 4, and B would end up being at -5, -2. So that would be me going through and following those instructions. And as I said earlier, I really hope that you have something different on your grid. Okay, we don't want to have the same thing. It kind of loses its effect. So even though you may be reluctant to keep working your way through with something that's going to look a little different than me, I think we're going to get something bigger out of it. Okay, now we're going to jump down. We're going to follow the next instruction. Okay, so I'm just going to shrink this down again, just so we can make sure we can see. Now step 2 asks us to count the squares to calculate the slope of AB. So I'm going to go through and I'm going to count my squares. To count those squares, I now need to go over to the right 5 and then another 3. So my run would be 8. And I would then go up 2 and another 4. That makes my run 6. Now you'll notice that there's an extra equal sign on the right. That equal sign is there in case we can reduce our fraction. So notice that I can reduce that fraction down to a slope of 3/4 when fully simplified. So maybe you can't reduce your fraction, and therefore you will have nothing to the right of that equal sign. For me, I can. I'm going to shrink it down. I'm just going to get rid of all those little dots because it's not a part of my original line segment. And then I think we should be good. Okay, so again, hopefully we match up in process, but not in picture. Okay, so we should have different things on the screen right now. Okay, we're going to keep it going. Okay, so now we come down to instruction 3. Now instruction 3 asks us to sketch in 2 other line segments to make a right triangle. Now there's some specific instructions to this, so I'm just going to blow that up. We've all got our picture there, so we don't have to worry so much about the picture. Step A asks me to drop a line from segment A. So let's walk through this one together. So for me to follow that instruction, to drop a line from A, then what I'm going to do is I might drop this line all the way down. Now, I hope we can see that red dotted line, but also that it doesn't have to go down that far. If the whole purpose of this is to make a right triangle, then all I really need to do is go down until I'm directly across from point B. Now I'm going to get rid of all of that, and I'm now going to make that solid right there. Okay. The next line instruction tells me to to extend a line segment from B. So now what I need to do is I need to extend a line segment across from B, again, with the whole intention of making a right triangle. Okay, the last part now says to go through and mark that corner at C. So I'm going to mark that corner as C, and it is a right angle. So I put in my little right angle marker. Now it tells me to go ahead and label the instructions of C. So if I label the coordinates of C. And so if I label my coordinates, I'm going to come in on 3, -2. Okay. Again, hopefully we've matched up in process, but we should have a different picture on our screen. So what I want you to do is pause the video now and do the same thing on your picture, or you've been pausing it as we've worked our way through, or we've done it together, and you're already down at this point. I'm going to say when you're ready and you have your diagram on your grid and ready to move on to the next instruction, then come back. Okay? So pause the video now. Okay, and so we're back. Now, we're going to have a different picture on our grid from what I have on mine, but I want us to follow through the same process as we move forward. Okay. We know that for us to calculate slope is rise over run. And what I'm going to do is I'm going to label on my graph what my rise and my run were on my triangle. So I should be able to see that I had a rise of 6 and a run of 8. Now on my diagram, I knew that that reduced to 3/4. Your diagram will have something different, hopefully. What I want us to examine right now then is a little bit of a calculation. And to do that, I want to highlight a process for us. Now you see that diagram, and I'm hoping you can see the 6 on my vertical side. What I want to do is I actually want to zero in on my vertical coordinates. And maybe you can think of an operation to do between 4 and -2 that would give you 6. Okay, let's take that and let's leave that for a second. Because again, I hope you can see my run on my diagram, my 8. And if we zero in, then maybe you can think about a number between my 3 and my -5 that would give me 8. And so we're just starting to try to think in terms of, okay, my coordinates and what I have at point A and point B. And perhaps you could think of something to put in place of that question mark. I'd like us to get down a little piece of theory, and hopefully we match up. That when you saw your rise, you might have saw that as the difference in your y coordinates. Notice if I was to replace that question mark with a subtraction, that means difference, then 4 subtract -2 gives me my 6. And we can see that distance of 6 on my diagram. What I want you to do, I want you to pause the video and take a look and see if the same thing happens on yours. So hopefully we ended up seeing that same pattern on your diagram. If we followed all those instructions and everything matches up, we should see that. We should be able to go a little quicker and notice that what we have on the bottom is the difference in our x coordinates. And you can see that if I was to replace that question mark with a subtraction, then 3 subtract my -5 gives me a +8. Check your diagram and see if we get the same thing. We should be able to see a distance on that horizontal side of our triangle. Now, what I want to do is I want to go through what's actually referred to as a formula for us. It's a slope coordinate formula. And this is going to be a way where we can calculate the slope of a line if we don't have its picture. If we're given the coordinates of the endpoints of a line segment, how we can calculate that slope. So I'm just going to shrink this down a little bit, and we're going to slide this up, because what you'll see directly below there is our conclusion, therefore. And what we have are really like 2 different formulas to be able to calculate it. What we could end up having, and you'll see me put this down in red, is we may have the y coordinate of one of our endpoints subtract the y coordinate of our other endpoint divided by the x coordinate of one of our endpoints divided by the x coordinate of the other one. Now, you take a look at what I have written down there, and that should look to you like 0/0, which is horribly wrong. Because what you see in red is y subtract y. The problem is, those aren't the same y's. And so what we do then is we designate each one of those points as like a 0.1 and a 0.2. So maybe I take a look at this diagram and I'm going to call my point A my 0.1. Oops, I want that in red. And then that makes my point B 0.2. And so now I can tell my y coordinates and my x coordinates apart because one of them's at 0.1 and the other one's at 0.2. The problem is my red formula doesn't show that yet. So if I was to then put on like 0.2 and 0.1, maybe we can see that then. Now, if we're struggling to see that this is 1 point, the x-coordinate and the y-coordinate of 0.2, and this is another point, the x-coordinate and the y-coordinate of 0.1, I could have this. It's y of point B minus the y of point A all over the x of point B minus the x at point A. But sometimes some people find the subscript, that small little number written under each y and x, as letters to be a little more confusing. So I'm going to get rid of that blue, and I'm actually going to get rid of my whole blue circles, and let's just put in that subscript. So what I can do then is I can use that formula to go through and calculate my slope. And I'd like you to follow along with me right now. So the slope of AB would equal the y-coordinate at 0.2, which is -2, subtract the y-coordinate at 0.1, which is 4, all over. Now the x-coordinate at 0.2, which is -5, subtract the x-coordinate at 0.1, and if I was to now make that calculation, that will be a -6 over a -8, which reduces to 3/4. Okay, I would like everyone to do the exact same thing that I just did on my picture. Let's make point B 0.2, and let's make point A 0.1, and I want you to go through and calculate your slope now. You should be able to use your picture to confirm your calculation. Okay, let's go ahead and do that now. Pause the video. Okay, we're back. Now, hopefully everything matched up. And what I want to do is, I just actually want to walk through this problem in a slightly different way. That what I want to do now is, I'm going to change which one I declared to be 0.1 and 0.2. I'm going to call point B 0.1 this time, and I'm going to call point A 0.2. So what I could end up having then is, if I follow my formula, and that's what I'm doing right here, I'm following this formula, that I have the y-coordinate at 0.2, which is now 4, subtract the y-coordinate at 0.1, which is -2, all over the x-coordinate at 0.2, which is 3, subtract the x-coordinate at 0.1, which is -5. And when I make that calculation, I get my 6/8, which is equal to 3/4. I want you to notice on my diagram, it doesn't matter which point I declare to be 0.1 or 0.2. As long as I subtract them, I get my slope. Now, I want to come back up to a part that we looked at earlier. This part. And I really want us to understand why our slope coordinate formula is what it is. If I was to ask you, which direction does your rise go? I would hope that everyone would say vertical. And if I asked you, well, which coordinates run vertically? I would hope everyone would tell me their y coordinates. So it makes sense that we subtract our y coordinates on top. If I was to ask you, well, which direction does our run go in? You should tell me horizontally. And if I ask, well, which coordinates run horizontally? You should be able to tell me your x coordinates. And so that's why my subtraction of my x coordinates occurs on the bottom. How do we calculate slope? It's rise over run. But some of us are going to put in a second little formula, if you want to think about it. That we're actually going to put in that our slope is y2 minus y1 over x2 minus x1. Now, what I want to do is just get some practice at using that formula so we can see what it feels like to go through that process. Okay, let's turn over the page. Okay, so when we take a look at the top of that page, you'll notice that I've given you 6 problems. And what we're going to do is we're going to go through and we're going to calculate the slope in each one of those cases. So let's just take a look at problem A to start it off. You do not have a picture now, but what I'm asking you to do is to find the slope of a line segment that would run from the first point at 4,2 to the second point at 9,6. And we should not need to draw a picture to count squares or units to get there. So what we're going to start off with is we're going to use our slope coordinate formula. And my suggestion to you is to write that formula down every time until it's drilled in and you don't even have to think about it. So my slope is y2 minus y1 over x2, yikes, minus x1. There's my formula. Now, what I need to do is I need to declare one of those points as point 2 and one of those points as point 1. So maybe I just say, well then, this is point 1 and this is point 2. And so now I'm going to blindly follow my formula. Okay. That means I take the y coordinate at point 2, which is 6, and I subtract the y coordinate at point 1, which is 2. That's all over. Now the x coordinate at point 2, which is 9, and the x coordinate at point 1, which is 4. Well, now in red, I see I just got some stuff I can calculate. 6 minus 2 over 9 minus 4. There we go. That could be one possible answer when I go through to calculate slope. Now, what I'm going to do, just so we can see it in this instance, is I'm going to get rid of declaring those as point 1 or point 2. And instead what I'm going to do is I'm going to call this one point 2 and this one point 1. So I could have an alternate solution in this case. I need us to see that it doesn't matter which one we declare point 2 or point 1. Okay, I'm going to follow my blue formula. Take the y coordinate at point 2 and subtract the y coordinate at point 1. Then take the x coordinate at point 2 and subtract the x coordinate at point 1. Well, now when I calculate that, I'm going to get a negative 4 over negative 5, which we should see a negative divided by a negative is a positive, and there's my 4/5. Notice it doesn't matter which point I declare to be point 1 and which one I declare to be point 2. I'm going to put on a third example because I want you to see what would be the really bad mistake. If we don't think about declaring, and so maybe I use those purple line, and I call the purple point, point 2, and I call the green point, point 1. Well, then I'm going to take one y value and subtract the other y value, and then the one x value and subtract the other x value. Can you see my mistake? That what happened was I took this x value, this y value, and subtracted this y value in the direction of my arrow. But then on my x, I went in the opposite direction. That would be me almost creating this formula. y2 minus y1 over x1 minus x2. And you notice that I'm not subtracting in the same direction. So we just have to be very careful. As long as we subtract in the same direction, then we know that we're good. So all I'm going to do is I'm going to put a little wavy line down in here just to help divide that a little bit. And now what I want to do is I want to go through question B together. Because what I would do if I were you is I wouldn't actually write point 1 or point 2 down. I would just think about what direction I'm going to find the difference. Okay, so I start off. I got to drill in my formula. Slope is y2 minus y1 over x2 minus x1. It is the difference in my y coordinates over the difference in my x coordinates. And now what I might do is I'm going to think about what direction I'm going to subtract in. So maybe I just take a look at this diagram and that list of points, and I go, I'm going to subtract in that direction. Okay, well now I'm going to use my formula. So I'm going to take the y coordinate at my first point, subtract the y coordinate of the other point. Notice I'm subtracting in the direction of my red arrow. That is all over. I have to subtract in the same direction. And as long as I take my time there and I make sure that I don't subtract in opposite directions, then I can just calculate and I am good. I like my red solution. But just like the last problem, I want you to imagine that I chose to subtract following my purple arrow. Well then, my solution would just look like this. 2 subtract my -3, the difference in my y's, over now the difference in my x's. When I calculate the top, calculate the bottom, I just notice that that's bad form because I have my negative on the bottom. So move it on the top or make the whole fraction negative. There we go. So hopefully not too bad. You guys can see that I don't have to declare a point 1 or point 2. I just have to make sure that I always subtract, find the difference in the same order. Okay, now it's time for us to jump in. I'd like you to go through and calculate the slope of the line segment created by the points in question C. Okay, pause the video, find it now. Okay, we should be back. So, maybe we wrote this down because, again, we're trying to drill in that formula. Slope is the difference in my y's over the difference in my x's, right? Slope is rise over run. If we followed the red arrow and we subtracted in that direction, then we should have a -9 subtract a -4. Now, can I even skip that step? That I'm going to have a bunch of people that go, yeah, but I can follow my integer operations pretty quickly. And I really don't want to write down double signs. So instead, when I subtract my tops, I notice that I'm going to be subtracting a -4. So to subtract a negative, I really add it. And you'll come right in on single signs. Now to do the same thing with my x's, I have to subtract in the same order. To subtract a -3 means I really add 3. And we now come in on a -5 on top over a -4 on the bottom. That fraction is fully reduced as long as I state that it's positive. A negative divided by a negative gives me a positive. So I'm going to bet and say that I might have matched up with your red solution. If I didn't, it's because you subtracted in the other order. So maybe you had this. One y coordinate, subtract a negative, so really add the other y coordinate, over the x coordinate, subtract a negative, so really add your other one. Okay, so there's a -4 plus 9 and a -3 plus, and we come right in. Okay, I better have matched up with your solution now. Okay, now I want you to jump into D. So same thing. I'd like you to go through and determine slope for problem D. Okay, pause the video now. Okay, and we should be back. Now, I want you guys to notice that if we went through and we calculated our slope, and if I chose to subtract in this direction, then I'm going to end up getting a 2 minus 2 over a 5 minus 1, which is a 0 over 4, and that's 0. Or you went through and you subtracted in this direction, which gave you a 2 minus 2 over a 1 minus 5, which was 0 over negative 4, which is 0. Okay, nobody's surprised that we got a 0. However, everyone's slope matched up at 0. Okay, I'd like to give you a little suggestion that when we go through and we calculate slope, we don't always blindly calculate slope. That what we're actually going to do is we're going to look at the points that make up our endpoints, and then we're going to figure out whether we need to actually calculate it or not. So what am I talking about? I want to go back and I want you to look at problem A. And I want you to listen to the questioning sequence that I go through to be able to solve problems A's instruction. I take a look at the first point, 4, 2. I look at the next point, 9, 6. And I'm actually thinking in my head, okay, 4, 2 might be around there. 9, 6 might be up there. I say to myself, is that a horizontal line or a vertical line? Like I actually say to myself, are those points directly across from each other or directly above each other? And if they're not, if they're on a slant somehow, then I calculate my slope. I figure out how far apart they are with their run, how far apart they are with their rise, and I calculate slope. But again, we're not using a picture. We're just thinking about it. So I want to come back in now on question B. I look at the first point. I look at the second point. -5, 2, and 1, -3. Are those points across from each other, or are they directly on top of each other? Nope, they're on a slant, so I calculate slope. Take a look at C. -3, -4, -7, -9. I might even start to say to myself, like, are they on a slope? Yep, they're on a slant, sorry. Yep, so I calculate slope. And now I want us to come in on D. 1, 2, and 5, 2. Are those points directly across from each other or above each other? Yes. So if we were to actually produce a quick picture, you have a point that is at 1, 2, and another point that is 5, 2. They are directly across from each other. That actually, if I was to go back and zero in on the points, I just want to highlight both those points have the same y-coordinate. And if they have the same y-coordinate, then they are directly across from each other. And what do we know about points that are directly across from each other? Like that line is a horizontal line. What do we know about the slope of a horizontal line? It is a slope of 0. That we actually didn't even have to do this work. We could have just found it. So as we move forward, this is how we show our maturity with the subject. I want us all to take a look at question E. Your first thought when you take a look at that, are the points across from each other or above each other? So give it like a quick 5 seconds, 10 seconds. -2, -3, -2, 5. Is this going to be a special type of circumstance? Hopefully we see that it would be a special type of circumstance. And so you could just come in with this answer. Now, why was that the case? Well, because if I was to plot those points, -2, -3, -2, 5, those points are above each other. They form a vertical line. Specifically, if I was to look back at the points, my x values are the same. And so points that have the same x value are vertical from each other. And we know that any line that's vertical has a slope that is undefined. Now, what does that look like if we actually were to calculate it? Well, maybe we're doing this. Okay, I know that my slope, I'm going to subtract in that direction. Is 5 subtract a -5, so I'm going to add it. 3. And then on the bottom, I have my -2 subtract a -2, so I'm going to add that. Well, I have 8 on top and I have 0 on the bottom, and I know that I can't take 8 and divide it by 0, so we are undefined. So you can clearly give me the red as an answer. There's no problem with that. But I think if we give everything a quick peek and to see would these form a horizontal line or a vertical line, that can allow us to show a little more maturity with the material. We can be a little more efficient, show greater understanding. Okay, what we're going to do is we're going to skip over ugly F. F should not be a problem. In all honesty, it shouldn't. It's just that the numbers are uglier. But we're going to leave F. Anybody who wants to work their way through F and give it a shot, feel free. Otherwise, we're going to jump on to the next problem. I want you to take a look at question 2. And we're going to try this one on our own. So, as you work your way through, if those 2 points form the endpoints of a line segment, then you need to name the coordinates of another point on that line segment. So I'd like you to go ahead and pause that video and give it a shot. Okay, and so we're back. So what we're going to do is we're going to tackle this problem, not necessarily in a way you have to. So I want to make sure that we all understand. I'm putting in some extra detail here, but I think it might be useful detail. So what I'm going to do is I'm just going to put on a quick sketch. I think that a skill that you can have in your back pocket that can be one of the most important skills that you ever have is the ability to draw a diagram. So many times do we feel more comfortable with stuff if we can see a picture to it. So to be able to put down a quick set of axes and then just go, okay, I have a point that's going to be at -2, 3. So I'm just like estimating where it would go, right? To the left a little bit and up a little bit. Now I have to put another point at 4, 6. So I'm going to go over a little bit more and up a little bit more. And I'm just going to estimate where 4, 6 would be. To just be able to put a quick sketch like that down can make it so much easier to understand a problem and then to start to trigger things to try. Don't ever, ever, ever be afraid to use up some time to just put on a quick sketch for something. I think it is a super useful tool. Okay, now that we have that picture, I've taken care of the red in the question. Now I got to deal with the blue. I need to name the coordinates of another point on that line segment. Okay, for us, what could be a really useful tool is knowing the slope of that line. And so what I'm going to do is I'm going to do a quick slope calculation. So I know that slope is y2 minus y1 over x2 minus x1. And most of us will get to the point where we never write down that formula. We just subtract our y coordinates and subtract our x coordinates. Notice on my denominator, I've got a plus in between because I'm subtracting a negative. Okay, now I can calculate that slope, and I get 3/6, and I know that that reduces to 1/2. Well, that slope of 1/2 actually becomes extremely important to me, because I know then that whenever my rise is 1, my run must be 2 anywhere along that line. If it was anything different, I would go off the line. And so I could start from a point and move according to slope. I could go over 2 and up 1. And I know I get back to that line. I could go over 2 and up 1. And I get back to that line. Over 2, up 1, back to that line. That anytime I move according to slope, I stay on that line. So now really all I'd have to do is just move according to slope. So if I was starting off at the point -2, 3, and I moved according to slope, then I'm going to end up finishing at this point that I'll call A. Well, if I move to the right 2, then that gets me to an x value of 0. And if I move up 1, then that gets me to a y value of 4. And so maybe you gave me the point 0, 4 as another point on that line. Maybe we dealt with it differently though. Like maybe we started all the way back here at 4, 6, and we went backwards. So we went backwards 2 and down 1. Well, if I went from 4, 6, and I went backwards, then that's going to maybe get me to this point, which maybe I'll call point B. Well, if I went backwards 2 from 4, that gets me to 2, and if I went down 1 from 6, that gets me to 5. Maybe you gave me the coordinates at point B. I'm going to bet and say that that should have been one of the 2 answers that you potentially gave. Are we good though that there are a bunch more? So what I'm going to do is I'm just going to clean up that diagram a little bit and go back to what we had at the very beginning. Because if we recognize that our slope is 1/2, then our slope being 1/2 could also mean then that for every run of 1, I have a slope or a y value, a rise, I should say, of 1/2. So maybe what I do is I say like, yeah, but I'm going to go back 1, which means I have to go down 1/2. And so maybe you finish at this that I'll call point C and say we are back 1, so that is 5, down 1/2. Well, 6 subtract 1/2 would be like 5.5. But we know that that's not great form, so we would actually put that as 11/2 as our y coordinate. Like, there's nothing wrong with that. So hopefully we could see we could have gone 1 unit this way and up 1/2 and got to a different answer again, and so on and so on. But I'm going to bet and say for most of us, you're given one of A or B. Okay, I'm going to bet also and say that a lot of us really like the appearance of a picture on that diagram to help us out. Never required, but I think you're silly at times not to include it. Okay, let's try the last problem. Okay, we take a look at problem 3, and it just says, if the line segment joining point A and point B has a slope of -5/8, determine the value of x. So if we scan that problem pretty quickly, we might recognize that we don't have all the coordinates at point B. We have the y coordinate of -1, but we're missing the x coordinate of x. Okay, what I'd like you to do is I'd like you to try to find the value for x. Okay, we're going to treat this one like a little bit of a problem-solving question. And I want you to try to stumble your way through it. Okay, pause the video now, come up with a solution. Okay, we're back. So, just as I stated earlier, sometimes a picture really helps. So, I would expect, yikes, to have a bunch of people that would have had like a quick set of axes. They can plot the point at A, which is at negative 5, 4. So maybe there's point A. And I'm just going to shrink that down a little bit. It tells you then that you have a slope of negative 5/8. And so maybe then I could go down 5, because that's what that is as my rise, and across 8, because that would be my run. Now, I don't know whether that's going to get me my answer or not, or maybe I'm fortunate enough that that works out that way. If I did move according to that slope, then I'm going to arrive at a value that is going to be some point, and I do know how to calculate the values for that because I can count my units. If I go to the right 8 from negative 5, I have an x value of 3. And if I can go down 5 from 4, I have a y value of negative 1. Now, I was really fortunate because when I scan back, that's a horrible arrow. I notice that that is the y coordinate that I needed. It is. Nice. So I like that. Therefore, I just got a little confirmation that my x value was 3. Now, what I also want to do is I want to show you another algebraic way to be able to go through and solve that. For the reason of what we finished off question 2 with. Like, what if getting to point B was actually like a part of a movement in a way? Like, I didn't really go down 5 and across 8. What if I went like down 5 halves and across 4? A manipulation of my slope. Some people might really like your algebraic method better because it will allow you to solve for that x value regardless of how ugly it is. So let's say I started off with my slope formula. I know that my slope is the difference in my x's minus the difference in my y's over the difference in my x's. Rise over run. And now what I'm going to do is I'm going to sub in every piece of information I know. It gave me the slope was negative 5/8. Notice I put my negative on the top. That way I can work with some good form. My y values would then be, and I can pick either one as long as I subtract in the same order. So I'm going to subtract according to that arrow. So I have my negative 1, subtract 4. And the difference in my x's would be x subtract a negative 5. So I've got my plus 5. Notice what you have in this scenario. You have an equation. You have numbers on both sides of the equal sign, and you have only one variable, x. Well, we know how to solve that. I'm going to spend one line collecting what I have on top. That is, I can put together my negative 1 and my minus 4. So there's a negative 5. Well, I can jump straight to this. And I hope that we're good for that. Take a look at what we have in the previous line. I have a fraction equal to a fraction, and the tops are equal. So negative 5 over 8 equals negative 5 over something. Well, since the tops are the same, then I know that my bottoms must be equal. So 8 equals x plus 5. And then you could go through and solve that pretty quick. However, I would have a bunch of people that would do this. And it's a little bit with the blinders on, but I don't think it's that bad of a thing. That from that line, they may say, hey, wait a sec, I know how to solve that. I can cross multiply. Because to get rid of a divide by x plus 5, I multiply by x plus 5. And to get rid of a divide by 8, I multiply by 8. That now they could expand the brackets on the left side and make it very mechanical and calculate the right side, and now get your x term all by itself. To get rid of a a multiply by negative 5, I divide by negative 5. And when I take my negative divided by negative and 15 divided by 5, I get 3. Some people really like that algebraic method because regardless of how ugly the value that was missing could be, you will always have a way to be able to get there. The graphical method, some people really like they like this graphical method. But we really kind of got to hope that our x value, and this our missing value, works out to be something that is relatively easy to find. Okay, 2 different ways to work your way through problem 3. I'm hoping that they're useful. Job now, jump in and get a little bit of practice. Good luck.